Welcome to another video. In this system of radical equations, so we want to solve for the value of x, and let's say the transformation of this is x raised to the power 1 over 4 plus x raised to the power of 1 over 6, everything equals to 12. And wow, so what I'm going to do here is, if I let x to be equals to y raised to the power of y raised to the power 12, so the reason is I want to make the power to be whole number, not fractional number. So here we have y raised to the power of 12 raised to the power of 1 over 4 plus y raised to the power of 12 raised to the power of 1 over 4, 1 over 6 rather. This equals to 12. Then, so 4 we go in 12 in 3 times, and we have y raised to the power of 3 plus while 6 in 12 is 2 times, and this becomes y raised to the power 2. And if I transfer this 12, we have negative 12 equal to 0 at this right hand side. And looking at this, here is a cubic equation, though I don't know the specific formula for it. But what I'm going to do here is, if I let this, or let's say I write this 12 in negative 8 and negative 4. So here we still have negative 12. And if I do the rearrangement of this number, if I combine y raised to the power 3 and negative 8 together, so we have y raised to the power 3 minus 8. Then y raised to the power 2 and 4. So we also combine it, and everything equal to 0. So this 8, if I write it in exponent form, and the 4 is also in exponent form, so this transformation becomes y raised to the power of 3 minus 2 to the power of 3. Then we have plus y raised to the power of 2 minus 2 to the power of 2, everything equal to 0. And I'm getting to this stage, so I'm going to use some identity. So I'll use the cubic identity and the square identity. But let's say we are given a raised to the power 3 minus b raised to the power 3. This is equals to a minus b bracket, then bracket a square plus ab and plus we have b square. So while for the second one, for the difference of 2 square, which is a raised to the power 2 minus b raised to the power 2, this becomes a minus b bracket and a plus b. So I'm applying these two identity in the third lines to the last. Then given that y is a and b is 2, so which it implies that we are going to write this as, so using the identity y minus 2 bracket, so y we still have y square plus 2y plus 4. And for the second one, it is x square minus b square. For y square minus 2 square is y minus 2 and y plus 2. So if I refer all this back to the fifth lines to the last, then we are going to have y minus 2 bracket, and we have y square plus 2y plus 4, and I close this bracket. Then we still have plus y minus 2 and y plus 2. This equal to 0. But looking at this, we have a common factor between the two, which is y minus 2. So taking out this y minus 2, we have a, let's say I create a larger bracket, then I'll put the rest in this bracket. So we have y squared plus 2y plus 4, then plus y plus 2, and everything equal to 0. So all right, let's further, let's add the like terms. Here we have y minus 2, the bracket y square plus 2y plus y, that is 3y, and we have plus 6, which is 4 plus 2. This equal to 0. And from this takes 2 equal to 0. So it's either y minus 2 equal to 0, or we have y squared plus 3y equal to 0. So therefore, we are going to have y minus 2 equal to 0. So following the quadratic rules. And the second one is y squared plus 3y plus 6 equal to 0. Okay, let's deal with the second one first. So we know that the first one is 2. But so this follows the quadratic formula as ax raised to the power 2 plus bx plus c equal to 0. But should I go to solve this? No, I will not solve it, because if a here equals to 1, b equals to 3, and c equal to 6, so we should know that whenever we have the value of c here greater than b, we should know that the discriminant for this is going to be negative. And if the discriminant is going to be negative, that is the value is always less than 0, so that is negative. And we are getting the complex root. So getting the complex root for this equation, so we don't need it, because the x here is a member of real number. And so therefore I will cancel this, and I will deal with the first one, which is y minus 2 equal to 0. So and y here equals to 2, so I'm solving it. And we know that from the first thing, we let x equals to y raised to power 12. And we have gotten the value of y to be 2, so therefore we have x equals to y raised to power of 12. Then replacing y here with 2, we got the result of 2 to the power of 12. And 2 to the power of 12 here is the real value for the value of x in the given radical problem. And this is how to go with this problem. I hope you learned something today. Thanks for watching, and don't forget the steps I used, and subscribe to this channel and like this video. Never stop learning. Bye bye.